Last class we have discussed a BCD adder or a decimal adder. Today we will discuss decoder. Again, decoder also comes under a combinational logic. Combinational logic which contains n number of inputs and 2 to the power of n number of outputs. This decoder basically used in many applications like memory. So in memory, in order to decode the address line, we are using the decoder, and also in case of 7 segment display, this is used as a driver. Now, in case of decoder, there are two types of decoders. One is active high decoder, another one is active low decoder. So in case of active high decoder, if I want to generate a SOP equation, I need AND gate or an OR gate. If I want to generate a POS equation using active high decoder, I need an AND gate or an OR gate. Similarly, with the help of active low decoder, if I want to generate any SOP equation, I need an AND gate or an OR gate. And if I want to generate a POS equation, I need AND gate or OR gate. So this is very important. You should remember this, then only it is very easy to design any active high decoder or active low decoder in order to generating a SOP equation or the POS equation. These two things you should remember. Next is, now we will design an active high decoder. Active high decoder. First we will see the logic of active high decoder. So this is the block diagram of active high decoder. In this active high decoder, first I will discuss 2:4 decoder. So 2:4 decoder means it's having 2 inputs and 2 power of n outputs. So 2 to the power of 2 is 4. There are 4 outputs: y0, y1, y2 and y3. So for this we need to construct a truth table. So if I construct a truth table for the same, so in the x0 and x1 are the input, y0, y1, y2 and y3 are the output. So in this case, the combinations 0, 0, 0, 1, 1, 0 and 1, 1 the combination, correct? So these are the outputs. So this is input and these are the output. In this case, if my input is 0, 0, only the y0 output is high and rest all 0. Similarly, if the input combination is 0, 1, then only the y1 is 1 and rest all 0. Similarly, if input is 1, 0, only the y2 is high, y2 output is high, this output is high, remaining all other outputs are in low. Similarly, for the last combination, 1, 1 combination, only this line get high, remaining all the lines are low. I mean to say, I have selected this line. So that point of time, this all are 0, only this line is get enabled. Now, with the help of this truth table, we can able to construct a equation. With the help of equation, we can possible to construct a logic diagram for the decoder. So now, I need to write an equation for y naught. So for the y naught, the area of interest is this. This is, I will select for my final equation. Then this become x naught bar, x1 bar. Similarly, for y1, I will select this. So y1 is equal to x naught bar, x1. Similarly for y2, x naught, x1 bar, x naught, x1 bar. Similarly for y3, this is the area of interest. In this case, x naught and the x1. For this, now we need to construct the logic diagram. So in this case, y naught, y1, y2, y3 are the output. X naught and x1 are the input. For this combination, I will take x naught and the x1. This is the x naught and this is the x naught bar I am getting in the output stage. And this is the x1 and here I am getting x naught bar. Now, I have 3 output. As I said, in order to generate a SOP equation, using active eye decoder, which gate I need to use? I need to use either AND gate or OR gate. So in this design, this is the SOP equation, correct? So in order to design this SOP equation, I need a AND gate or OR gate. For this logic diagram, I will use AND gate. So I will take here AND gate, 1 AND gate, 2 AND gate, 3 AND gate, and this is the 4th AND gate. Now I will make the connection. So for the first equation y naught, x naught bar and x1 bar, this is the x naught bar, this is the x naught bar, and this is the x1 bar. This is the point I will take. So here I will get x1 and here I will get x naught bar. Similarly for the next equation, of y1, in this case I will take x naught bar, this is the point, then I will take x1. Similarly for the last case, the third case, we need to take x naught and x1 bar. Similarly, for the last case, x naught and x1, take x naught and x1. So this is the logic diagram for active high decoder. Similarly, now we will discuss active low decoder. 2:4 active low decoder. Now we will discuss that active low decoder. Active low decoder. Again, in this case, active low decoder, this is the block diagram. So this is 2:4 decoder. This is active low. So here it contains the x0 and the x1. Output is having a bubble. See, in this case there are 4 output. Each output contains the bubble. This is basically an active low decoder. So this is the active low decoder. Y0, Y1, Y2 and the Y3. Now I will write the truth table for the same. So next we need to construct a truth table for the active low decoder. Again, in this case, X0 and X1 are the inputs, Y0, Y1, Y2 and Y3 are the output. Again, in this case, the combinations were 0, 0, 0, 1, 1, 0 and 1, 1 combination. If I select 0, 0, obviously we know that Y1, Y0 output get activates. In this case, instead of 1, we are getting 0 and rest all is 1, 1. Getting this is only 1 is 0 and rest all 1. This is just opposite of active high decoder. In case of active high decoder, whichever the line we are selecting, that output is 1. But in case of active low decoder, whichever the line we are selecting, that output is 0. Remaining all other outputs are 1, 1. Similarly, for 0, 1, this is 0, this is 1 and this is 0, rest all 1, 1. Similarly, for the next combination, for 1, 0, only Y2 output is 0 and rest all is 1, 1. Similarly, for last combination, only the Y3 output is 0 and remaining all in high state. So now, with the help of this truth table, we can able to write the Boolean equation. In the Boolean equation, now I will write the Boolean equation. So Y0 is equal to X1 bar and X0 bar. Y1 is equal to X1 bar, X0. Y2 is equal to X1, X0 bar. Similarly, Y3 is equal to X1, X0. Now, as I said, active low decoder is good for generating the POS equation. Remember that active low decoder most of the time we need to use for generating the POS equation. Active low decoder is especially used for generating the POS equation, and the active high decoder is especially used to generate the SOP equation. Remember that active high decoder is required to generating the SOP equation. Active low decoder is useful to generate the POS equation. Now, we know that, so in order to generate any POS equation using active low decoder, we need to use, see, in case of active low decoder, again the thing is, this is the SOP equation one which we got. See here, Y0 equal to X1 X0 bar, Y1 equal to X1 bar X0, Y2 equal to X1 X0, Y3 equal to X1 X0. Clear? So this is the SOP equation. In order to generate this SOP equation, with the help of active low decoder, we need to use either an AND gate or NOR gate. So now I will use the NAND gate. So now we will see that what we are getting. Now initially I will take two input. One is X1, another one is X0. Now I will take 4 NAND gate. As I said, with the help of active low decoder, if I want to generate any SOP equation, I need a NAND gate. In this, first one is X1 bar, X0 bar, X1 bar and X0 bar, X0 bar and X1 bar. The next one is X0, X1 bar. I will take X0 and this is the X0 bar. The next is, so this is X1, X1 x naught bar, and the last one x1 x naught, x1 and the x naught. See, this is the equation for active, this is the logic diagram for active low decoder, and the equation is, see here, if I write x1 bar into x naught bar, this is the whole bar. So what equation I am getting here? This is x1 plus x2, correct? This is actually a min term, or this is the pause equation. That's why I said with the help of active low decoder, it is very easy to construct the pause equation. Fine. So this is, after that we are getting x1 plus x0. Why? Because here bubble is there. See that bubble means whatever we are providing that become complemented. 0 means what? 0 it indicates the 0 term. If we are interested with 0 means that is pause equation. Correct? We already learned that. So that is a max term. So that's why 0 means we should get x1 plus x0, not the bar. Similarly, the next one is x1 bar, x0 whole bar. This become x1 plus x0 bar. So this is the m1 one which we got. So this is this, yeah, m0, or we can say m1, right? See, like this, see the each and everything, see 0, we are interested with 0 means it will produce the pause equation. This is m0, m1, I went to x1 plus x2 bar, correct? x1, x1, x0, x1 and the x0. Fine. Similarly, for the last case, this is x1, x0 bar, whole bar. This become x1 bar plus x0. This is the min term 3, sorry, max term 3. Correct? All the pause equation we called as max terms. The last one is x1 into x0 whole bar. This become x1 bar into x0 bar, and this become, sorry, m2, and this is the m3. So this is how we are generating the pause equation with the help of active low decoder. One more thing you should observe here. See, in the block diagram, I have used the bubble. Why? Because see here we are using NAND gate instead of AND gate. Okay, this will get complement in case of the active low decoder. Now we will see one problem. So how to design the 3:8 decoder? Okay, so for example, if I want to design a 3:8 decoder, if I want to generate a 3:8 decoder, 3:8 decoder, we need 3 inputs, isn't it? That is n is equal to 3 and 2 to the power of n, that is 2 to the power of 3 is equal to 8. So then how many inputs we need? So in this case we need 3 input. One is x2, x1 and x0, and in the output stage we need y0, y1, y2, y3, y4, y5, y6 and the y7. So the combination in this case is, the combination is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and this is 1, 1, 1. In this case, so here I want to design an active high decoder. Here I want to design an active high decoder. So then we know that if it is 0, 0, the line 1 which selected is 1 and rest all is 0. Similarly, for the next case, only y1 output is 1 and remaining all are 0. Similarly, for the next case, only y2 output is 1 and remaining all 0. Similarly, for this case, only y3 is 1 and remaining all are 0. Similarly, for fourth condition, only y4 is 1 and remaining all 0. Similarly, for the fifth condition, only y5 is 1 remaining all 0. In the sixth condition, only y6 is 1 and remaining all are 0. For the last case, only y7 is 1 and remaining all are 0. So in this case, we need to write an equation only for these ones. Wherever the 1 is there, that is what our interested. Why? Because in active I decoder, it is very easy to generate the swap equation. If I want to write a swap equation, then my interest is only whichever the output is 1. Then for that, for example, now I will write the equation for y0, y1, y2, y3, y4, y5, y6, y7, right? So for y0, x2 bar, x1 bar, x0 bar. Similarly for y1, x2 bar, x1 bar, x0. Similarly for y2, x2 bar, x1, x0 bar. Similarly for y3, x2 bar, x1, x0. Similarly for y4, x2, x1 bar, x0 bar. y5, x2, x2 bar, x0. Similarly y6, x2, x2, x1 and x0 bar. Similarly for y7, x2, x1 and the x0. So this is the equation for y0 to y7. For this we need to construct a logic diagram. Again, it is very easy to construct the logic diagram for the same. First we need to draw all the inputs, x2 and its complement. Similarly x1 and its complement. Similarly x0 and its complement. So in this case we need totally 8 AND gates, y0, y1, y2, y3, y4, y5, y6 and the y7. There are 8 AND gates we required. Why? Because if I want to generate an active high decoder, then I need to use either AND gate or the OR gate. And especially active high decoder holds good for generating the swap equation. Now I will complete the connection. This is first one is x2 bar, x1 bar and the x0 bar. For the next case, this is x0, x1 bar, x2 bar. For the next case, x0 bar, x1, x2 bar. Similarly for the next case, x0, x1, x2 bar. This case, this is only the x2, x1 bar and the x0 bar. Similarly for the next case, it is x2, x1 bar and the x0. Similarly for this case, it is x2, x1, x0 bar. For the last case, x2, x1 and x0. This is how we can possible to generate an 3:8 decoder, 3:8 active high decoder, and I have generated the swap equation with the help of AND gate.